Hey folks, welcome back for another episode of Code Club. I am Pat Schloss. If we haven't met before, I am a professor at the University of Michigan in Ann Arbor, Michigan, and I am really excited to help people improve their data visualization practices. Part of that includes doing a better job of designing visualizations, but also a big part of that is using the programming language R to create data visualizations. In this episode, I am going to take a data visualization that was recently published in the journal Nature, and we are going to refactor it to try to make it a bit more effective. I'll leave it there. And so what is the visual I'm thinking about? Well, this is it here. This is taken from figure 1 of the paper I'm interested in, looking at panels I through T, and my take on this set of panels is that this should really be one panel. Maybe you might call it 4 panels, but it's basically 12 panels of the same type of data for 3 different drugs. And so they have wild type and they have a mutant. That's the wild type is the WT, the mutant is the S33W. And then they've got this Lyra as a drug, Dan as a drug, Orpho as a drug. Those are abbreviations. And then they have vehicle to go along with that, right? And so then they have this, this is a study being done in mice looking at GLP-1 receptor agonists. And so it is a weight loss study in mice. And so the top row of panels is the standard diet consumption by these different types of mice, whether they're wild type or they've been basically humanized, so basically had their receptor gene mutated from a serine to a tryptophan, that's the S and the W, so that the drugs that work for humans would work for mice. Not all drugs that work for humans work for mice because of this genetic mutation. The bottom row, though, is the same mice, but given a high-fat diet, and looking at their weight loss, their consumption, in this case, looking at their consumption of the diet. All right, so as you are logging in, I would love it if you let us know where you are joining from. I've got Mike from the UK, John from Barrington, Illinois, Leo from Germany, Teresa from Portugal. Welcome, and I notice many of you are regulars to the live stream, so thank you very much. And again, if you are new or if you're watching a recording of this, know that this is kind of the third of 3 parts of my program with this data visualization. The first is a newsletter. And so if you go to rifamonas.org, which I will throw over here in the chat, you can sign up for my mailing list. And that will get you basically a once a week email from me, kind of outlining other things that I have going on, but also then, as you'll see in this newsletter, talking about a data visualization and either kind of some scientific take on it or just kind of sociological take on it in this case, or me describing it like a really high level, how I would go about recreating that visualization. And so the title of this newsletter kind of says what was interesting to me. What is causing the large number of figures in modern papers? Figure 1, that you can see I took I through T and showed you that earlier, has Z panels. It has 26 panels in it. And this was not the only figure in this paper that had Z panels, right? I think I counted a total of like 112 panels in the 5 main figures in the paper. Plus there were 10 extended data figures that easily had over 200 figures. So why is this? And so I kind of give some of my opinions as you kind of read through the rest of the newsletter. And I will go ahead, and I did go ahead and put a link to that in the chat. So encourage you to check that out. The paper that I'm taking this from also is published in the journal Nature. And this is a open access paper, as you can see over here. I almost did a double take because I didn't see it, but open access right there. And let's see, the other reason I picked this figure, this paper, was because the data are publicly accessible. And so you can find that by coming down to the section source data down here. And you'll notice that there's a source data 1 with a download link. So we'll come back to that. I'm seeing in the notes, let's see, Mark saying that the last week's link to the code threw a 404 error. Sorry about that. I will check that and fix that after this live stream. But know that you can go down below to the description for this episode after I've uploaded the live stream or after I finish the live stream. And you can get all the code that I'm writing today. Last week was a doozy. It was a 3-hour live stream. This should not be a 3-hour live stream. I think this will be a little bit more calm than that effort that I think ultimately had 5 plots all being pulled together using patchwork. And that was hard. That took 3 hours. We were all fried. I was fried mentally at the end of that. All right. And so again, I said this is that figure 1 that we're going to be taking this from. So the other thing that you should know is that on Mondays, I post a live stream. And so this not a live stream, I post a video that is a critique of the visualization. And so I mainly am focused in this video on these panels I through T and doing what I consider a constructive critique of these panels, right? I'm not doing the whole 26 panels, don't worry, but these 12, where I see, again, a lot of redundancy, and think about how we might pull those together. The main takeaway from that critique is that when they talk about this figure in the article, they're talking about figure 1, J, L, and N, or figure 1, I, K, M, right? Or O, Q, S, or P, R, T. They're basically comparing the wild type to each other, and then the humanized, or the S33W, to each other. And then they compare the high-fat diet separate from the standard diet. Okay, so that was something that got me thinking about, can't we combine these together? And my general thought would be that we have 2 types of diet, so I could see that still being 2 rows of panels, but could we accumulate or pull together the wild type data and the S33W data to be in separate panels? So then we'd have 4 panels or 4 facets, and because they're all part of the same experiment, I'd really consider that to be 1 panel. I mean, whatever, if you wanted to call it 4 panels, that's still 1/3 of 12, which is a lot. Some other things that I'll just briefly point out through here, that the time on the x-axis is not proportional to the spacing between the values, although I guess you could make an argument that it is on log2 scale. I don't think that's what they meant to do, because the space between 1 and 2 hours is the same as the space between 2 and 4 hours. I also noticed over here that the vehicle and ortho over here in panel M, those lines are a bit thicker than we have for everything else. And that as they were compiling all this together, I think the vertical positioning wasn't consistent, and also the horizontal width wasn't consistent, right? So like the x-axis here in J and P is more narrow than it is over in I and O, right? And so again, by moving to a faceted approach using ggplot2, I think we should be able to get over all those problems. The other thing I have in mind, because we're going to have the vehicle and the drug, that's going to make for 6 lines in each of the 4 facets, that might get a bit busy. And so my thought would be to make the vehicle like a light gray in the background, and then to have the drug be the different colors and use the same colors that they've got here. And that by having the vehicles should all be the same result. The vehicles were slightly different for at least 2 of the drugs, maybe all 3 of the drugs. But again, if it's a vehicle, then it shouldn't have an impact on the amount of diet being consumed, right? That's supposed to be inert and not matter. And so it doesn't really matter, I think, that the vehicles are for different drugs, especially if they overlap with each other, like they mostly appear to do. And so that's kind of my mindset of where I want to go with today's video, okay? Let's see, we've also got Mark from Melbourne, and we also have Lori, who's in Saskatchewan, which is, I believe, north and west of me currently. Saskatchewan is always north and west of me, but she is currently in Saskatchewan. All right, so I have our studio session going here. I have a script that I've started called panelslivestream.r, and I've already gone through and created the download file function to automatically download the data for me. And that is right here, as you can see, figure 1 XLSX. I also have a figure that's being saved in the same aspect ratio as this, right? And so another thought I have is that the text in the original here is quite small, and I'm zooming in pretty far on it. But my hope is that by going to 4 different panels, that we'll have more space. Again, here, like the x-axis, the y-axis are all the same, and so there's a lot of duplication that I think is taking up valuable space that would allow us to make each of the facets larger so it's easier to see the text, easier to see the data. So that's the plan. That's where we're going, okay? And again, if you have comments or thoughts along the way, by all means, leave me a comment in the chat, and that would be great. So, like I said, we already have figure 1 XLSX, and even though we're going to work with figure 1 XLSX in R, let's open up the Excel workbook to see what this looks like. And so, yes, there are Z pages. I don't think there's actually 26 pages in here because some of the first panels were diagrams or pictures. So we're not going to worry about that. But again, we are interested in, let me pull that back up, I through T. And so we can see figure I here looks like this, right? And we can see J looks like this. I'm not going to go through all of them. We're going to let R do that for us. But we can see the general framework. And this actually does appear to be tidy, although it is small. So in the first column, we have the drug, whether it's the liraglutide, that's the lira, or the saline, which is the vehicle. And then we have the wild type. So in this case, it's, or the genotype, we have the wild type. And then they have the time, the number of animals, the mean, and the standard error of the mean, okay? And so the error bars that we see, we're not gonna have the raw data to calculate those standard errors. These are the mean plus or minus the standard error. So we'll have that standard error data even if we can't calculate it from scratch. So let's go ahead and read this in. So we'll go ahead and do readxl, and we'll then do figure 1, I think it's figure _1.xlsx, and we'll do sheet equals, and again, that's going to be figure space 1i. And we read that in, and we get this tibble, right? And so that's great. And so one thought would be, well, now we need to repeat this to T, which is not going to be my goal, okay? So what I would like to do is to perhaps create a loop with like a map function to create a data frame that has all 12 panels worth of data in one data frame so that I can then feed that into ggplot too, okay? And so again, it's all coming from the same XLSX workbook, and the sheet format is the same for all of these. Like, it might be hard to see at the bottom, but we can see it's all figure space 1 and then the letter of the panel. And we're going from I through T. And so if we do letters, letters is a built-in vector of lowercase letters. If you do letters in all caps, you get the all caps letters, right? I think that's kind of a cool tool. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So letters 9 should be I, which it is. And then letters 21, I think should be T. Nope, that's a fence post error. 20 is T, okay? And so what I could do would be like letters 9 to 20 will be the vector of lowercase letters from I through T. And because I'm lazy and don't want to count them, I could do length, and that should be 12, which it is. Cool. All right. So what I'm trying to do is basically make this value that I have highlighted here for the sheet. And so I could use paste to do that, or I could use glue. I like glue. So let's use glue. Glue is installed when you install the tidyverse. Sorry for all the scrolling here. And so what I could do would be like glue, and then in quotes, we could then put figure space 1, and then in curly braces, the R code, which would be the letters 9:20. And then that gets us a vector of values, right? Cool, huh? And so what that allows me to do then, I think, is to pipe this to a map. And so typically on this channel, when I use map, I'm using it on a column and a data frame. But here I am using it, I'm using it as a vector, right? And so we might turn it into a data frame, but for now, let's roll with map. And so the map is going to take the data coming through the pipeline, and we'll put that in the .x argument. And so then we need to give it a function. And so the function is going to be this, right? And the sheet is going to be the .x, which is the argument. And because it's going to take arguments, this needs to have a tilde in front of it. So if I run that, it didn't get any error messages, which is always nice and wonderful to see. I then get, I see I get 12 separate data frames, right? They're all 6 by 6. I'm noticing this one has maybe 7 columns, right? It's got the standard deviation in there. All right. So, so now we've got these data frames, right? And we can then pool them together. So let's go ahead then, and we can pipe that to bind rows. And that then gets us a single data frame, 17 rows and 8 columns. And I see then that there's 2 extra columns that I wasn't anticipating. That's the SDFI. So I think that's the standard deviation, and then the type. I'm not sure what those are. So let's go ahead and do a pipe that to drop an A on type. And so this should then give me anything that has a value in type, right? And so now I see there's IP. I think for later experiments in the study, sometimes the drugs were given via IP, which is an intraperitoneal injection. And in other cases, it was given orally. That's one of the motivations for this study, was to come up with drugs that could be given orally versus injection. You may have seen that in some of the advertisement for like Wegovy and whatever, is that it's like a monthly injection. Although I have seen recent commercials for an oral pill. So anyway, so I don't think we need this SD and FI, but one thing that I don't see in here is the diet, right? And so we need a column to indicate the diet. And so let's think here. It would be nice to get in some indication of the panel, right? And I think in bind rows, I can do .id equals panel. And so that then tells me the panel, right? And it's a bit of a risk, but I could, of course, do like a mutate on panel to be letters on panel. And then that, it was not happy. Because panel is a character, right? Like it's a character up here. So I can do like as.numeric on panel. And so then I have the different panels, right? But, you know, I think I would prefer to have it be numeric. If I do like filter panel equals 1, or panel equals 7, those should both be the lira, right? And so the top is the standard diet and the bottom is the high fat diet, right? And so I think what I'll do is leave that panel, and although I think I could do it this way also. I'm thinking like the next step would be like a filter, like if panel is less than 7, or what I could do would be like panel less than n, right? Well, I don't want to do filter, I want to do another mutate, and we'll do diet equals if else panel less than n, then it's going to be SD. Otherwise, it's going to be HFD. And need a closing parenthesis there. And so now what we see is we've got HFD. And so it's, why is it HFD? And again, that's because this is, why is it HFD? Oh, because panel is, because N is a variable, not a string, right? So if I put the quotes around it, now I've got the letter, right? And so I think that's okay. Just confirming, I think I want to be less than or equal to N, right? And that way then, let's do a count on panel and diet. And we should get, we see that we get the 12 rows, right? Okay. And that we have, everything is standard diet. I think I'm trying to be too cute with this step here. I'm going to go ahead and make it numeric. So we'll do as.numeric on panel. And so then if it's less than or equal to 6, then we'll give SD for diet. Otherwise, we'll do HFD for diet. And so now we can see that we have the SD and the HFD. And it's, of course, making my panel character type when I do the count. So I'm not super concerned about that at this point. So, all right, here we go. We've got our data and we know what panel it's coming from. We know the diet, and that's good. I really, at this point, have information in here I don't need. So let's go ahead and do a select to remove the columns I don't need. I don't need the panel anymore because I have kind of the unique information from the injection, which is the drug, the genotype, and the diet. So actually, instead of saying what I don't want, why don't I say what I do want? And so I'm going to say drug equals injection. And what that does is that gives me a column called drug, right? And so I can use that equal sign to select the column and to rename it. And so then I'll do genotype equals genotype. And then we'll do time equals time. I could also have done like 2 lower on these, but I have to do the select function anyway to get what I want. Then we'll also do diet, which is already named right. And then I'm going to do mean equals mean fi, SEM equals SEM fi. And so then that gives me the columns I want, right? So the drug, the genotype, the time, and the diet with the mean and the standard error of the mean. And so again, I'm thinking ahead to putting this into ggplot, so I can remove this readxl. And I'm going to want time. Well, let me show you something first. I'm thinking about this time column, right? And currently it's of type character because it's listed as 1 hour. And if I do like count on time, I actually see that they have HOUR and HR in different places, right? So that's not great. So again, we have this, and you know what? I think looking at this, I think I actually do need the panel because I'm going to have saline show up in multiple places. So for just the moment, I'm going to leave in the panel. And so let's do a filter panel equals 1 to get that liraglutide data. And we could do ggplot AES, x equals time, y equals mean. And then we could do like color equals drug. And yeah, I think that's good. We could also do like y min equals mean minus SEM, y max equals mean plus SEM. And we could put this on separate lines. And we could do like geom line. And that reminds me that I also need a group. So the group would be the drug. And maybe actually I don't need the group because I've got the color, but sometimes it's nice to have that there anyway. And then we'll also do a geom error bar. And so this should get us something that looks a lot like what they had, right? Again, this would be this. Well, I didn't include the line. And where is the line? Maybe I do need the group. Yes. Okay. There we go. So that is, and now this is analogous to what we have over here. Of course, the colors are different, the styling is different. But what you can hopefully see, and the reason I went through creating this, is that the increment on the x-axis is evenly spaced, but it's not spaced proportionate to the amount of time between the labels, right? And so what we'd like is to make it go one unit, 2, and then 2 units to 4. And in some of these cases, I think it might make the lines look more linear. Whereas one of the comments I had over here is like, if you look at like this, because of the spacing on the x-axis, it actually makes it look like there's an exponential increase in diet consumption, which was not something they commented on in their story because it's not true, right? But I think is an artifact, again, of how they are presenting the data. All right, so for the time being, let's come back up here and let's go ahead and modify the time. So I'm going to come back into this mutate statement, and I'm going to take time and do str remove on time. And I'm going to remove a pattern. So we're going to use a regular expression. So if I did HR, that's going to that's going to remove the cases like I have here of HR. But I saw way back up here, here, right? Where some cases it's HOUR. And so what I could do would be like H, and then any number of characters repeated 0 or more times, followed by an R. And so that then, if I come here and do a count on time, I should, it's not happy. Let's see, string must be a vector, not a function. And that's probably because at this point, it's a capital T time, not a lowercase t time. All right. And it's still upset with me. Why are you upset with me? Let's look at this real quick. I've got time as a character. Oh, right. I need to update both times. So let's, I could probably also make this lowercase t time, but let's leave that there for now. Now when we run it, we see that we've got 1, 2, 4, and we don't have the H's or the HR or the HOUR. I can also pipe this to as.numeric. And this then will give me my n now as an integer, my time now as a double rather than as a character, right? And so now when I do this, if I go ahead and remove that count time and look at what we have over here, we see that the units on the labels on the x-axis are being spaced by the interval between the time, not categorical like we had before. Okay, so I think the data now are more or less in the right format that we want. The last thing I'll say kind of about this type of plot, or I guess it was more like this, is that to recreate their plot, you would basically repeat this 12 times. And there is a way in Patchwork to vectorize things so that you're basically mapping over each value in a data frame or each panel in a data frame to create the panels you want. I don't want to do that because I want to make a better plot. I'm not going to recreate this plot. I'm going to go ahead and refactor it to make it kind of how I think it should have been made. But know that that is something you could do in Patchwork. And so if you want some extra practice, go ahead and try that with Patchwork. All right, so let's see. So let's go ahead and I will remove that filter. And again, just to remind ourselves of what we have here, we have this data frame that has the panel, the drug, the genotype, the time, the type of diet, and then the mean diet consumed and the standard error of the mean. And what we're going to then do is pipe that into ggplot, where again on the x-axis we've got the time, the y is the mean, The color is the drug. It's being grouped by the drug. And then we have our ymin and ymax for the error bar. I think they also have a plotting symbol on there. So I guess I should also add geom point. And well, this is what that looks like, because again, we have all of the data thrown together, but now at least we have those plotting symbols in there, right? So if I had done like filter panel equals 1, then I'd get that, right? And so that, of course, has that plotting symbol thrown in. Okay, so again, that's not what we want. So I'm going to go ahead and remove that. But again, if we leave that in, then we get all the data in one panel. But what I would like is to have 2 rows. I want one row as they have for the standard diet and another row for the high-fat diet. And then I want 2 columns, one for the wild type and one for the S33W, the humanized mice. So to do that, what we'll do is go ahead and pipe this or add this to facet grid. And so then on the rows, I want the diet. And then on the columns, I want the genotype. I think I got that right, but that might be wrong. And so if I remove my face, you can now see we've got the diets on the rows and the genotypes in the columns, right? And so that's cool. Let's go ahead and render that with the aspect ratio that was used in the original figure. And so let me kind of move these panels so they're easier to see. Right. And so I think you can already see that we're going to make changes here. But again, the bottom panel, the bottom plot takes up the same space as the top plot, right? And hopefully you agree with me that you can see how this is going to make the data easier to see, right? It's going to allow us to have bigger fonts. It's going to allow us to most likely write out the full name of the drug rather than these abbreviations, which don't mean much to anybody. And it will also, and most importantly, make it easier to make these comparisons that we want to make between our different drugs for the different combinations of the genotype or the diet, okay? So now the goal is to realize this vision and make this look a bit more attractive. I think the first thing I'm going to start with is the ordering of the columns and the rows. So in the paper, they talked about the wild type after the humanized mice, which didn't make any sense to me. And so if I were coaching them, if I was the PI, which I'm not, I would have talked about the wild type first. And that's because the wild type is the control. They're trying to validate a humanized mouse model for studying these drugs so that they are working with drugs that work in humans, right? And so they want to see that like what they expect to have happen in mice happens in mice that haven't been genetically modified. So I would have talked about that first, just to be like, hey, we see exactly what we're supposed to see in mice. Check, that's a control. Now let's move on to the humanized mice. So I'm going to put the wild type on the left. I mean, they did that too originally, but just that was something about the writing. So let's put the wild type first, the humanized second, and then we want the standard diet on top and the high-fat diet on the bottom. And so to do that, we are going to use factors. So we'll come back up here and let's see. I think we can do that in the mutate. And yeah, so let's go ahead and we're doing diet here. So let's go ahead and do another line for diet. We'll do factor on diet. We'll do levels equals, and I think we want it to go, so again, this is going in alphabetical, H before S. So we're going to do SD and then HFD, run that. And so now what we see is we've got the standard diet on top, the high-fat diet on the bottom. Now we want to do the same thing with the drug, or as it's being called up here, the injection, right? And so we'll then do, you know, I don't really, I'm going to move this around because I don't like doing things with these capital letters. Like I'm renaming the things. So let's do this up here. Let's rename them and then do the modifications. And so that doesn't exist. And so we're going to make diet equals diet. And let's see what this looks like. Diet doesn't exist. Oh, and that, right, diet doesn't exist because I add it later. All right. So Steven says, either I would do what they did, but as all axes are the same, I would remove all but the outer axes to unclutter. Okay. So I guess I would push back on that, and that in the writing, in the paper, they are talking about this light blue line compared to this red line compared to this purple line, right? And so if we leave it the same way, but we remove the axes, then that doesn't really solve what I see as like the biggest problem with this figure, is that it's hard to make the comparisons. So I don't know if we're maybe saying the same thing, but that's kind of my reaction, Stephen, and kind of how I would think about it. And in terms of the vehicle, my plan is to make the vehicle the same color, maybe kind of like this gray that they have for the vehicle over here in the ortho. But we'll get there. But that's my thought, and maybe why I would push back a little bit from your suggestion of removing all but the outer axes to unclutter them. I think we're going to do the same type of thing, kind of like we have down here. So, all right. And so again, that works. And then we want to add the mutate to get the diet, right? And so now here, we're going to make time lowercase. Sorry, I know I went through this already, but let's run this just to make sure things look good. They look good. All right. And so we refactored the diet. Let's also refactor the genotype. And so we'll do factor genotype levels equals C, and then it's capitalized. So wild type, and then S33W. And there we go. We now have wild type on the left and S33W on the right. Excellent. Now what I'd like to do is we'll come back to the labels of the standard diet and the high fat diet, but let's turn our attention to the color. And what I'm noticing is that there are two values for the vehicle. There's saline and there's vehicle, right? There's not 5 different things, right? There's the 3 drugs and the 2 vehicles. So let's go ahead and change the saline to vehicle. And so we can do that back up here, where maybe I'll, let's do it before time. Okay, so we'll do drug equals if else drug equals saline, then make it vehicle, otherwise keep it as drug. Okay. And so now what we see is that we have the vehicle and we have the 3 drugs. Okay. Hey Sayed, welcome from Somalia. Great to have you as well. All right, so now we've got the vehicle and the 3 drugs, but I would like to have this legend be in the same order. Yeah. So Mark, that's my goal, is if we put all the comparisons on the same plot, will it help with the mental picture and ease of comparison? That's my goal. So you might say, like, what if we put the S33W and the wild type on the same panel? We'll experiment with that. But my thought is that that's going to get too busy, right? Or maybe we could put the standard diet and the high fat diet in the same panel for the same genotype. I also think that's going to get too busy. One argument for keeping them apart is that they don't compare, at least in the text, between like wild type and S33W, or between the standard diet and the high fat diet. And so that would be kind of, for me, a reason to keep them apart, and not I think if you add busyness, then you've got to be willing to accept that sacrifice. And I don't think they are, because they're not talking about those comparisons. So I think keeping them as 4 plots rather than 1 or 2 or 12 is maybe the right sweet spot, but we can play with that here in a bit. So let's go ahead and reorder the drugs. And so we'll come in here and we'll do drug equals factor drug. And we'll do levels equals. I'm going to put the vehicle first. And then we'll put the liraglutide. And then it was the danuglipron. Horrible names. Let's put these on separate lines. And then the ortho is not, it's not ortho. And I actually have it spelled out over here. I'll grab that. And so we'll get that name in. And so now when we run it, we should get the drugs in the order we wanted. Although, in the data I have orpho, but I gave it the label, the orphaglutide, right? Or orphoglipron. So, so this needs to be orpho. And I think what I'll do actually is I'm going to relabel them as well as reorder them. So let's put the levels like this. And I know that's wrong, but bear with me. So what we can do in factor is I'll copy this and I'll make this labels like that. And this should be orpho, right? So we're going to relabel orpho to be orphoglipron. And, I probably could have done the same thing up here, where I could have had like, maybe relabeled saline to be vehicle, but I don't know. So now we've got our orphoglipron with the full name there, looking good. Now let's go ahead and change the colors, right? So as I already showed you, I cheated a little bit, and I've got this vector of colors. And so I'm going to plop this in here. And normally what I use is a digital color meter, but just to kind of speed up time a little bit, I grabbed the values beforehand just to kind of speed things up. But we'll do scale color manual. And this will be our values equals all that. And yeah, let's roll with that. And it's upset with me because I have one too many parentheses. All right. So now what we see is we've got a light gray. We've got the liraglutide in the same blue that they have over here, the same red that they have up here, and the same purple that they have here. Okay. Nice, huh? All right, let's go ahead and I'm going to go ahead and let's go ahead and play with the labels. So I'm going to get rid of this drug label, and I'm going to change the time to be time in hours like they have. So let's go ahead and do plus labs. We'll do color equals NA, and then we'll do X equals time in hours. And then I'm going to remove the Y. So we'll give that as an NA. Oh, I didn't mean NA. I meant null. I know someone was yelling. I heard you, honest. All right. There we go. So we no longer have the title over here, and we no longer have the y-axis value. And so to do the y-axis value, I'm actually going to use these labels for the rows, okay? And so let's build up to that. So the first thing I'm going to do is I'm going to move these labels from the right side to the left side. This is one of my favorite tricks with facet grid or with facet wrap. And so what we could do is switch equals y. And so that should move the y labels to the left. Sure enough, we now have those labels were over here on the right, and now they're on the left, but they're inside the y-axis text, right? And so to get them on the outside, I can do plus theme, and I can do strip dot placement equals outside. And that will then put my strip labels on the outside, okay? Now, what we could do is I can, like we saw with the ortho, I can change the label for the SD and the HFD to better match what they have for their labels, okay? So let's do that. We'll come back up to where we did the diet factor. Again, we have the levels here, and then we'll do a labels equals, and I'm going to cheat as always and copy that and then get things cleaned up. Active phase, and then we'll do \n, and I'll do standard diet consumed. Maybe make that lowercase. And then if we copy this down, it's going to be inactive phase, and then high fat diet consumed. Okay, so let's see what this looks like. And so now what you can see is that we have those labels, right? We have active phase, standard diet consumed. The font is really big and runs off the side of those labels. I prefer not to have abbreviations if possible, especially when it's jargon like SD versus HFD. And I would prefer to spell it out in a figure, because oftentimes a figure might be consumed independently of the rest of the article. And so spelling that out would be helpful. So I don't know. The thing that we could try then would be like strip.text equals element text size equals 8. And that shrinks it a little bit. It's almost there. What if we do like 7? Oh, that's like so close. So we could push it to like 3 lines. I guess it depends on like how willing I am to die on the hill of not having abbreviations. So if I put another line break there, I now have 3 lines, and I've got that. And I think maybe like this phase, maybe it should be like a colon, because like these are like different phases of the mice lives. I don't know. I could see going back to having exactly what they have. Well, let me leave it like this for a little bit. I think we're gonna have plenty of room to the right to expand out, and that is again in size 7. So if I went to 8, it could be a little bit bigger and it would still fit in there, right? And you can see that that title's already a lot larger than what they had by default. So maybe I'll leave 8. And then we also need to make the x-axis 8 to be the same size, right? So we then need axis.text, or axis title.x, element text, size equals 8, to get the time in hours to be the same size as this, right? And so again, remember, this is the strip text, not the title. We removed the title, right? So that's the strip text. We'll get rid of this gray background in a moment. Let's go ahead and shrink down the text on the X and Y axis. I don't know if you can tell, but it's also gray. This is kind of a persistent challenge. I feel like I get annoyed by that. This too is a different color than that black. Let's see, how can I show you that? If we pull out the digital color meter, because I just love this thing, you can see that that's 4D, 4D, 4D. That's a gray color, whereas that is black. Well, actually, it's not black. It's a dark gray. Interesting. All right. So if I wanted everything to be black, I could do that. And so maybe I will do that. So let's go ahead and do axis.text equals element text. Let's do size equals 6 and color equals black. That needs to be in quotes. We can also do axis.ticks equals element line, color equals black. And so then that, again, shrinks that down. I still feel like this 2 is larger than that 2. And maybe it doesn't need to be quite so small. If I made that like 7, oh, that's 76, that's too big. Something like that is even larger. So Mark's suggesting within facet wrap or facet, what is it? Facet grid, we could use label wrap gen. And I think, where is label wrap gen from? That is from ggplot 2. And let's try that. That's cool. So we could, that's in facet grid. So we could do labeler equals label wrap gen width equals 25. So I do this, I don't think anything's gonna, oh, it stripped out the \ends. And so maybe we shrink it down to 20. Right, something like that. And that way, the advantage of using that helper function like this is that I don't have to worry about where to put the line breaks, right? And that it's automatically wrapping the label for me at, I wonder what 20 is. What is that? If I go back to help, let's see, that's width. Label wrap gen, width equals 25. Number of characters before wrapping the strip. So it's in terms of characters. Interesting. I would kind of prefer to have it in terms of space, maybe. I don't know. Yeah, whatever. That's cool. So thank you for that. That's helpful. And I guess thinking about it in terms of characters, like if I shrink the font to like 6, then I could fit more characters. So I have to like change multiple things at the same time. So anyway, this is cool. And thanks for that. Thanks for that addition. That's wonderful. All right. So we've got all those labels. Let's go ahead and get rid of the background. And so we'll also do panel.grid equals element blank, which of course gets rid of those background grid lines. And then we can also do panel.background element blank, and that gets rid of that. You might also be asking, like, couldn't you just do this with like theme classic? And yes, you're correct. And I think, but I'm kind of modifying a lot of this stuff already. So if I had done like theme classic, it would look like that, right? And so I'm still going to have to fiddle with the text a bit, right? And I don't know. I think it's helpful to have these helper functions like theme classic. Let me see, what would I change? If I had to start with theme classic, I still want the size to be 7. I wouldn't need to set the color to be black. Wouldn't need to change the ticks. I wouldn't need to worry about the background. All right. Oh, and I forgot the plus sign. Right, so this is what we've got. And yeah, I don't know. Maybe this is a good time also to go ahead and remove the backgrounds around the strips. And so again, that is here, that's the strip.background element blank. So in, let me just see if I can show you over here. So this is what the strips looked like with theme gray, which is the default. it's a rectangle with gray fill. And then in Theme Classic, it's a rectangle still with a white fill, but a black border, right? And so by removing the strip background, we can see then that we no longer have the border, right? And so that's cool. I would like my 0 to cross at the x-axis. I don't know if you can see it from your vantage point, but it doesn't quite cross at the same spot. And we can change that by coming up to, we'll do up after scale, I'll do scale Y continuous, and we'll do limits equals 0. I have to do C 0 comma NA, and then we'll do expand equals expansion, and then 0 0. So that's basically turning off the expansion. And that now, hopefully you can see maybe from your perspective that that 0 tick is crossing right at the x-axis. And yeah, I think that looks pretty good. And we have the same top to the y-axis effectively, right? So nice. All right. Now the maybe we could go ahead and I'm wondering if we want these titles to be a little bit stronger, or maybe we could write out what they are. So let's do that real quick. And so we had that here. I guess this is going to be a day of doing relabeling things with labels. There's another way to relabel factors or relabel facets within Facet Grid using that labeler function. I find that this is a little bit easier to do. I mean, if you're not doing other modifications of like diet and genotype elsewhere. So let's do labels, and we'll do wild type. I think it's hyphenated. And then we'll also do humanized. And I'm going to go ahead and put in a line break and do S33W in parentheses. And so now we've got that. It didn't do my line break though. Oh, it didn't do my line break. It didn't do my line break because it stripped it out to do the 20 characters to do this, right? So this labeler worked on both the top and the side labels, which is interesting. I'm going to, for the moment, take this out. And let's see what it looks like wrapping over the line. Something like that. I don't know. I think in this case I like having that go over. I like having it on 2 lines. I don't know. So I think I'm going to go ahead and for the time being, I'm going to comment that out. I'll leave that in there again if you want the code to follow along. And let me take a break. We've been at this an hour. Remember where we are. And so I think we're pretty close here. And some things that I'm thinking about are just kind of the general spacing of things, the widths of those caps on the error bars. It looks like we've got some clipping of this error bar here. I think our legend could be a little bit more compact. And I don't think we need the full width that we have. And yeah, okay. And we've got Ali G from Turkey. Welcome. The other thing I'll just, as we're taking a pause here, is just to mention, as I usually do, that I am very happy to work one-on-one with people or to work with research groups to help improve your own data visualizations, whether that's designing the visualizations or implementing them in R. And if this is something you would like to learn more about, then down below in the description, there's a link where you can set up a 30-minute complimentary meeting to talk with me about your needs and how I might be able to fulfill those needs. And yeah, feel free to sign up for a slot there and we can start a conversation and see where it goes from there. All right. So Mark says, I think we can use labeler on the rows or columns. Let me look at facet grid here real quick. I know that if I'm not using factor to relabel things, I can certainly do it on rows and columns separately. So that's that labeler argument. Oh, yeah, I'm not gonna. I find that the labeler stuff becomes a bit of a black hole. It just kind of sucks you in. And I'm gonna roll with this for now, but I suspect you're right that there's a way to set the labeler. Okay, I'm gonna try one thing. So let's try labeler. I think you can do like diet equals this. Right, so we can set the labeler function for the column I want. Oh, I've got an extra parenthesis here. Okay. And then I need a parenthesis here. Okay, let's see if this works. Nope. Maybe this needs to be a list, or this needs to be labeler. Aha. I think that did it. And let's do 30 here just to see if it's working. Yeah. All right. Okay. Thank you for pushing me, Mark. Yeah. He's got it in the text there, but basically we can say diet equals this function. And then I could also say like genotype equals, actually, let's do that, right? Let's do genotype equals label wrap gen width equals, is it 10? And that way then I can also remove this \n. Oh, and I did label wrap instead of label wrap gen. Okay, there we go. Oh, it's upset with me. So I'm too excited to hit those returns. Let's check my parentheses. That goes there. That goes there. Okay. There we go. Yeah. Cool. Nice. Thank you for that, Mark. So as I mentioned, one thing I noticed is that there's some clipping up here at the top. And I could turn off the clipping, or I could increase my Y limit. So here I have NA. And so it's picking the top value, but it's not adding any expansion, right? So if we do like 2.4, that adds a little bit more space to the top here, and I no longer have the clipping at the top. So I think that's great. Let's go ahead and let's see. Trying to think of what to do next. Let's go ahead and I'm going to go ahead and remove the margin that's all the way around. There's quite a bit of space up here above the strips. And actually, if I turn off that background, I can see that there is a margin around the strip text, right? So let's go ahead and do strip text. And then we can do like margin equals margin. And again, by default, the margin is going to be 0. And so now we can see that that is using that full space. And so now if I remove this background, there is my G here is getting clipped on the bottom. And so what I could do is maybe add a little bit of margin to the bottom. And so maybe I could do like B equals 1. And it's, yeah, that's not, I could do 2. And I think maybe it's not 2 I want, but R? Something's, oh yeah. Yeah, so sometimes when things are on their side, you get funkiness. I think, but if I do R, then I'm adding to the right of this and to the Y, the columns, right? So I think what I'll do is I'll go ahead and turn that off. And then what you could also do is like strip dot clip equals off. And so that will turn off the clipping on the strip, right? So now I've got that G there. But you might say, I want a little bit more spacing there. And so what I'm going to do actually is do axis.text.y equals element text, margin equals margin, and then L equals, if we do like 3, that adds some space to the left of that text without adding any weird margins to those titles. Of course, I'm noticing now that like it's removing all the space between the text and the tick. So let's also add in here then R equals 1. And so that gets us a little bit more spacing there. Let's also come in here and we'll do axis.line equals element line. And I want to make it a little bit thinner. So we'll do line width equals 0.2. And so that makes that thinner, kind of on the same thickness as theirs. We also need to do that with the ticks, right? So we do axis.ticks equals element line width equals 0.2. And so then those are a bit thinner and not as obtrusive, not as bold and pronounced. So I like that. Okay, those caps are pretty wide, and yeah, let's go ahead and shrink those down just because they look kind of obnoxious. And so we can do that up here in geom error bar with width equals, I don't know what to pick. Let's try 0.2. And actually, that doesn't look so bad. And maybe if we did like 0.1. I think that's pretty good. One thing I'm noticing though, now that we've like made those smaller, is that there's only one line for the vehicle on each of these 4 plots. And there should be 3 lines for the vehicle, right? And so you can kind of see some funny stuff, like there's the gray line here, and then it shoots up and then goes over. And we kind of see the same thing here, right? This one looks a little bit straighter just because they're doing a better job of falling on top of each other. So let's fix that. And so we used the group equals drug to tell ggplot what points need to get grouped together. And so I think we need to revisit that. So again, we did group equals drug. And I think what we want to do is maybe the combination of the drug and the panel, right? So we have the panel. So what if we do like paste drug panel? And so now what we see is we have a separate line for each of the vehicles, right? So that's pretty cool. And something I'm noticing though is that the vehicle line appears to be on top of everything else. Right, so like in this wild type, it's kind of hard to see the ortho data behind the gray line. And the gray line is going over top of the blue line for the liraglutide. And I think it's above, I think the gray is on top of everything else. So what happens if we sort, What happens if we sort by the drug? So we do arrange drug. So that kind of helped. And yeah. I guess the first thing I want to point out is that, like, I think the vehicle lines are all pretty close to each other, right? They're all pretty similar. They're not bang on, but you can also see that, like, these other lines for, like, the Dan and the Orpho, at least with wild type standard diet, are right up there with the vehicle. Whereas the Lyra is the one that's active in mice. And so, whereas the Dan and the Orpho are not active in mice, right? And so when you humanize the mice, you then get the response that you see in humans, right? And so I'm thinking about this, that maybe what we need to do, though, is, because it's not quite working the way I'd hoped, is let's make a combined variable. So I'm going to call this, like, grouping set. And then here I'll do grouping set equals that. And now nothing should change. But I want to make this grouping set a factor. And we want to arrange by a grouping set. So let's do, like, we'll do a factor. And then levels equals, so what should we do? So I want to have I think the vehicle, the Lyra, the Dan. And let's see, what is it doing for grouping variable here already? Drug not found. Oh, because nope. Drug is there. Oh, I need another parenthesis. All right. So let's see, we've got the grouping set is a factor. And if I arrange by the grouping set, then it's going alphabetical rather than by the grouping set, right? And so maybe what we could do would be like FCT reorder that by drug. Will that work? Nope. It's upset. So, all right. Let's do factor, paste that, and then we'll do levels. And so we're going to want to go, like, let's do, let's see. I'm thinking, so I want the drug first, and then I want the panel. So what am I thinking? I'm thinking, oh, I might be overthinking this. So if I look at grouping set not found. Oh. Oh, come on. Oh, because I don't have grouping set. All right. Get that back. Sorry about this. Remove that. So what I'm trying to do is alter how the things are laid down, right? And so, yeah, I think what I want to do is, I'm trying to, like, avoid having to write effectively 6 lines, but that might be unavoidable. So let's do factor. This is our grouping set. And then our levels will be why wouldn't it be paste drug panel? But it's going to be in the order of drug panel, right? And so this might be distinct on that. Oh, or unique. And so, yeah, that's not doing it the way I want it. Okay, so let me, actually, I've got this code here. I'm going to copy this. And so our levels will be like this. And so I'm going to do, I'm going to make these strings. I'm going to remove the colors for right now. Clean this up. All right. And so then we're going to do wrap. Let's see, we've got glue. So we'll do glue, vehicle, okay. Let me comment this out for a minute. And then I want to do unique or full grouping set. This is what I'll do. And then unique. And I've got an extra parenthesis somewhere. Okay, where are you? Okay, let me get rid of that. Oh, I need an extra parenthesis there. Okay. And so, okay. Okay. So what I've got is these are the combinations that are showing up, and there's 24 of these, right? And so I'm going to go ahead and copy that, and then in here, I'm going to do my levels equals what I'm going to do next. And hopefully this works. So I'll go ahead and plop that in. Actually, I'm going to bring that over here and open up a new file. And actually, it'll be a lot easier if I remove that space back here. All right, so we'll do paste 0 on this. Sorry for all this. Let me do paste 0. Okay, now I've got it without the space. I don't really care about the names themselves, but they need to be in quotes. And actually, I'll do one more thing. I'm going to let R do the heavy lifting for me on this, right? I'll do unique, and then I'll do a sort. Okay. Cool. All right. Try this again. And we'll go ahead and, okay, if I've got a space, I'm going to use a regex, and I'm going to, let's see, if I've got a space, one or more spaces, I'm going to replace with a space and a quote. Does that work? Ta-da! And then if I've got a space, one or more spaces, I'm going to then get the closing quote by doing quote space, replace all. I think that worked, right? And so now I can then replace a space with a comma space, replace all, cool. And so now I've got this stuff I can remove. the line number easily enough. There's the ortho, get rid of that. And now I've got my vehicle stuff. Okay. And so I want the vehicle up at the top. Don't want this number. And right. And then I want to get things in the right order. All right. Like so. Bear with me, sorry. So we've got the vehicles in the order, and then we want the lira, and then we want the dan, and then we want the ortho. And we just kind of make sure these are in numerical order by panel. Oh, I need the 12 also, like so. Okay. Cut, paste that into here. And again, we'll do levels equals all that. And I can get rid of this now. And, oh, that's like, let's see, can I should be able to go edit, maybe it's in code, reflow, reformat section. I don't want that. Code, reindent lines. Oh, it really didn't do what I wanted it to do. All right, I'm gonna leave it there and not worry about it for right now. So I feel like you're watching me toil with this too much. So now what we've got, when I sort it by grouping set, is I've got vehicle 1 first. And so if I fold that into my pipeline, at long last, I see that my data, or for the drugs, is on top of those gray lines. All right, all that for that little effect. So thank you for bearing with me. Sorry that took so long. All right, cool. So I think that looks pretty good. Now, my critique of the visual currently is that it's too wide, right? That I would like it to be a bit boxier, if you know what I mean. And again, like what's remarkable is like this is the same size as the original. It's the same data. The text is larger. The data is easier to compare. And I think that's a win, right? So I'm going to go ahead, move that up. And I'll save this with the original aspect ratio. Let's bring down the width to say 5. And we get something like that, right? So again, it's the same height, but it's more narrow. And I think like just that aspect ratio is a bit more appealing to me for whatever reason. The legend is a little too spaced out, I think, right? So let's do some work with the legend. So we'll do legend dot key dot size. We can do unit, and let's do like 8 pt. Let's also do legend dot text equals element text. I need a comma here before I forget, and then size. So the axis text is 7. Let's go ahead and make it 7 as well. And so what I do, I made the key smaller and I made the text smaller. And so that, I think, nicely pulled that together. Maybe a little bit more separation. And so what we could do is like, the key size might be 10, something like that. And so I think that looks better. And then there's also like legend keys spacing. And here we could do like unit, let's do 3 pt. I don't know what it is by default. I should know this stuff, but whatever. So I think that looks good. And maybe the box could be, the legend could be a little bit closer to the text. So we'll do legend.box.spacing unit 3 pt. And so that brings that a little bit closer as well. And so at this point, maybe we could come in even closer. I don't know, if we did like 4.5, you get something like that. Let's see. Mark asks, why did you not remove it to the top as a variable then call? I'm not sure. Line widths could be narrower. Yeah, I agree. They're kind of thick. So we could do that back up here with like geom line. So our axis lines are 0.2. Let's make this line 0.3. Line width equals 0.3. And then our error bars, let's do the same. And so that cleans those up a bit and looks pretty good. I'm still seeing, I'm not going to mess with this any further, but with like the wild type, you can kind of see the error bar overlaps with, like this gray error bar overlaps with the purple text. And that is because when back up here, we did geom error bar after geom point, right? And so the error bars are always going to be on top of the points. I guess if I switch the order, maybe that looks a bit better. There we don't, well, but then like we have this red one where we've lost the top error bar, right? And so I think a alternative strategy to what I've done here would be to break the data frame into two parts. So one part would be the vehicle and the other part then would be the drugs. And so then we could lay down the lines, the points, the error bars for the vehicle, and then we could rerun those commands without filtering out the vehicle. And that way then we would know that our 3 drugs are on top of the vehicle. I'm not going to worry about that for right now. I think if I was doing this for a publication, I probably would go back and do that just so that I'm not worried about things overlapping. Could you put stat and geom line for the error bar and point? Yeah, there might be a way to do it with the stat for the error bar and point. I'm thinking though that if I was calculating it raw, yeah. So if I had the raw data and I could calculate the standard error, then I would do all that in one command, and then I wouldn't worry about things overlapping on top of each other. So in a way, this is a bit of a fiction just because I don't have the raw data. I have the standard errors and the means. And so I could do stat summary with the line and the point range to get the same effect. So good points. All right. One other thing that I would like to add, because people get really excited about this, are the stars to indicate significance. Okay. And my thought would be to have the stars go under the line and be in the color of the drug, right? So up here, right, they put the stars actually on top of the vehicle. But what if we put the stars like down here or down here, like 3 light blue stars, 3 light blue stars here, right? And that way then the color would match the color of the drug. We'd have the stars to indicate significance and people would be happy, okay? So that's what I'm gonna do to kind of close this out from here, okay? So to do that, I am going to use the annotate function, and I think I'm gonna have 4 annotate functions. Or is it annotate or annotation? Annotate, okay. So we're gonna have 4 annotate functions. So we'll do the first one, obviously, and then go from there. So let's do, so the first thing we need to put is geom equals text. And then we'll do x is going to be 2, y is going to be right under that, under this, right? So let's say like 0.25, and then label is going to be 3 stars, and then our color is going to be the light blue, which was this hex code here. Okay, and then we also need to say layout equals 1 to indicate we want that in this first facet. And so there's our 3 stars, right? I think that font size might be, I don't know if it's too big. Let's do like size equals 8, size.unit equals pt. And so I think that's good. And maybe it needs to come down a little bit. So let's do like 0.2. Something like that, okay? So that's my idea, right? It's in place of these stars to put those colored stars in place on my panel, okay? So we also need to do the one for 4 hours. And so again, we could do x2, we can make that a vector, and 4, and then y, 0.2, let's do 0.3, and then label is going to be both of those as well. And then the color is going to be a vector, and it's going to be the same color twice. I actually don't think I need to say the same color twice or the same label twice. Let's see what this looks like. No errors. And then we can see we've got those blue stars, right? Cool. So now we basically want to wash and repeat. So I'm going to go ahead and copy this down. And this is going to be layout 2. And again, this is wrong, but it's going to put it right over here for panel 2. And so if we look at the humanized, which again is this S33W on the top row, so it's going to be J, L, and N, then the blue is going to be a single star and triple star, right? And so now we've got a single star and a triple star. I think that triple star can probably move up closer to the data. And so let's maybe make that 0.4. So that's good. And then let's see, is there, so the red has triple stars and the purple has triple stars. Okay. And so we'll go ahead and do 2 and 4, 2 and 4. And I think we can do 0.2, 0.4. And then we're going to do triple stars, 4 more of those. And are there any single stars? Yes, there's a single star actually for the final one. So we'll have to come in here and do 1, 2, 4, and maybe like 0.2, 0.2, 0.4. And let's run it with the same color. Oh, it's upset with me because I've got different number of labels. Oh, because I need a single star in here. All right, so we've got the triple star, but it's not showing up. Oh, it's not showing up because I put them all right on top of each other, of course. All right. And so I can see that that first star is way too high, and that should probably be 0, right? And so, so it's going to be 0.2. Let's do 0.1, 0.3, and then we'll do 0.1, 0.3. That feels wrong. Okay. So, okay. So this is going to take like some fiddling, right? So this needs to be down probably at 0. Right. That's at 0. You can see it there. It's right on it though. And so maybe it needs to be like negative 0.05. And it should complain. Yeah. It's complaining because that's below the plotting area. So I think what we'll do is we'll come back up to here. And I can do chord Cartesian. And I'll do ylim equals this stuff. And I'll do clip equals off. Get a plus in there. And I misspelled Cartesian clearly. Chord. There we go. And so now I've got my blue star down there. And let's see. In SSW3, so that's supposed to be a single star for the light blue, and then a triple star for the red. And I should also have a triple star for the purple. So I'm confusing myself clearly. So this is the blue. So let's go ahead and get those colors right. So there's 2 for the blue, and then there's two for the red, and that's going to be, that's there. Thank you for hanging out with me this morning. Hopefully you're still enjoying this. And I said 2 for the red, yep. And then we have the purple, and there's going to be 3 of the purple. And we'll throw that in. And maybe put this over separate lines. All right, so let's use that to help us to see where the points are. And so again, we have the blue and then the red, but I think I reversed, wait. Okay, so the red, let's start at time 2. Okay, so the blue is right, it's a single star. And we now want the red. So at 2, that's the 3rd slot, and that's at 0.1, but that's at the same point as that. So I think this should be down to 0. There we go. So we have the blue, the red, the purple, the blue, the red, the purple. I think this final one could maybe be nudged up a bit. And so that's here. Maybe it could be, is that 0.5 too high? Maybe 4.5. So do 0.45, 0.35, and then 0.25. I think, whatever. I put a 4. It probably doesn't really matter. And there we go. Right. So now we've got those labels in there matching. And again, we're going to repeat for the wild type, where again, we're only going to have the blue have a significant value, right? So looking at panel O, Q, and S. So I'll go ahead and grab this first one and copy it down. I need a plus, that. And again, this is going to be layout 3. And we're going to want 1, 2, and 4. And let's see, it's going to be like, let's do like 0.3, 0.4, 0.5. And I think the first one is a single star and then a double star. Like so. Let's see what that looks like. And I got a plus here accidentally. Right. Copying paste. When you paste, sometimes you bring along some baggage. Okay, and so that's pretty good. I'm not going to futz too much more with like the vertical placement. Maybe I will because I can't help myself. Let's do these up to like 4, 5, and 5, 5. And that first one can probably go up too. All right. Something like that. All right, cool. And now we want to do this final one. And that probably looks the most like this annotate here. So I'll copy this down. And again, we're looking at J, L, and N. And but in the bottom row, right? And so there's a single star, a triple star, and a single star. So it's all 9 points are significant, right? And so we want 1, 2, 4, 1, 2, 4. And then here maybe we do like 0 0.1, 0.2, 0.45, bam, bam. So this is 1, 2, 3, 4, 5, 6, 7, 8. And then let's do like 0.4, and that's good. And it's going to go 1, 2, 3, 1, 2, 3, and then 3, 3, 3. So it's 3, 3, 3. And then we have 1, 2, 2. So we'll do 1, 2, 2. Cool. And then we're going to repeat these colors, each of them 3 times. Like so. And then this needs to be layout 4. So if we look at this, make sure we don't get any errors, and then we can adjust where we've put things, right? And so we have, let's see. So there's supposed to be, let's see, we need to do some adjusting here. Let's see, so we've got, our blue is missing. And so that's at 1, that's at 0.1. Oh, it's overlapping with this other one. So let's make this, so I think 0.1 is the right place. Actually, I'm going to move the first one. No, I'm going to leave that there at 0.1, move this to 0.2, and then, sorry, 0, 0.0. That's wrong. Maybe that should be like 0.5. And then this is 0. So let's make this maybe negative 0.01. And we'll start with time 1 and kind of work our way across. And so what we're seeing is that we've got the red, and then we've got the blue and the purple. And what I'm thinking is maybe we'll put the blue just to a smidge to the left and the purple to the right of that a notch, so that we're not going down below 0. And so let's do 0.75. And then here let's do 1.25. We'll adjust this again. And then the Y position is going to be the same for the blue and the purple. So, right. And so that was this negative. So we'll make that 0.1. And there we go. That didn't entirely work. Why didn't that work? I think I put, oh, yes. I put the red at 1.25. So that should be at 1, and the purple should be at 1.25. Okay, like that. And that is kind of the idea I'm going for, but that's too far out. So let's maybe do 0.9 and 1.1. So I think it looks a little bit better. I don't know that it's ideal, but I think it's okay. So now let's look at the second one, our 2. And basically where the red is where I want my blue. And so, again, that's the second slot I have as 0.2. And it should be, I think, 0.35. And then let's make this 0.25. And then 0.15. And I think that's good. The same order. Good, good. And now finally, our 4, where I think the blue is pretty close, or maybe the purple is where I want it. So the Y for the purple is 0.4. So let's maybe make this 0.4, and then make this 0.3, and make this 0.2. And voila, there we go. All right, well, what do you think? So again, this is the same data, the same height being devoted to these panels. And in the paper, what they're saying is that when you give a wild type mouse these drugs, that they only respond to eating less of when they're on the liraglutide, right? And that's regardless if it's standard diet or the high fat diet. And so that is much easier to see, I argue, in my version than their version, right? Like I can see, okay, here's wild type, here's standard chow, that line is lower than everything else. Easy. If I did it up here, I'm like, okay, here's this line. Okay, now I have to come over here. There's that line. Yes, it's different from this. Over here, is this wild type? Yes. Is that different? Yes, that's different. Right? It's much more involved, I think. Hopefully I'm not, being overly dramatic about this, but I think it's just much easier to make that comparison. It's in the same space, and everything also is bigger, which makes it easier to see. I don't know. I think that's important. I think that's helpful. Let me know what you think of how I've done this. Like I said, the one thing that is still a little bit annoying is the ordering of the error bars and the points. But if I think there's 2 ways to do it. So the first that was raised in the chat was if we have if we had the raw data, then we would be calculating the standard error and the mean. And then we could use stat summary to calculate that all together so that those points and the error bars come together effectively as like a package deal. And so we wouldn't have this problem. The alternative approach then, with the data I have, would be to basically make the plot the geomes twice, to run the geomes twice. Once where I'm filtering out the vehicle, and once where I'm only using the vehicle, right? So I'd put the vehicle down first, and then I would put the other stuff on top of it, okay? So let me show you one other thing, which would be, I don't think this is gonna work. So I think the other comparison that would be useful to try might be the humanized, I don't know, would maybe be it doesn't really matter because I think it's gonna be hard anyway. But let's put the standard diet and the high fat diet. Let's make it 1 row, okay? And let's see what it looks like. So again, we can come back up here and we can turn off our grid, and we'll do facet wrap. And I'm not going to worry so much about the switch stuff or the labeler stuff because I think we're going to get a sense that it's probably a bit much. So we'll do dot tilde diet, and then we'll do n. Let's do n row equals 1. And then maybe what we'll do is, I said genotype, right? So then let's do, say, shape equals genotype. And there we go. So again, I mean, there's a lot like wrong here. Did I do what I said I was going to do? I think I'm getting tired and I may have like misspoke. Yeah, okay, whatever. It doesn't matter. I think the point is that it's busy, right? That like, I guess the triangle is the humanized and the circle is the wild type, right? And so we can see that the the liraglutide is low for everything. I think it's just too busy, and so I'm not a fan. So I'm going to put this back. And again, as I had said earlier, again, if you're going off the text and what comparisons the authors were most interested in, I don't think that was something that they were interested in, right? And so I'm happy to leave it with 4 separate panels instead of 12 separate panels, or 2 panels or 1 panel. Okay, I think there is a trade-off between being too busy or not too busy. All right. What if you put the error bars as the bottom layer? So I tried that, and what would happen is like this error bar here would be hidden by the blue dot, right? So let me do that here quickly. You're kind of talking me into trying this. If I do it like that, right? So then we kind of lost the bottom of the purple, right? Okay, let me try this. So I'm going to leave this as is. And I'm going to, let's see, take that out. I'm going to call this D for data. And so then if I do D piped into this, I get the same result, right? Okay, so what I can do would be, so the first argument to like geom line is, well, it's mapping and then it's data, right? So what I could do would be like data equals filter D drug equals vehicle. I need a close parenthesis there. So I'm going to copy this down for geom point and geom error bar. And so now when I run this, I should only get the vehicle lines, right? Cool. Now what I can do is I can, where'd I go? I'm going to copy this down, and I'll do drug not equal to vehicle. And this then, well, let me remove or comment out the drug equals vehicle. Now I should get the colored non-grade lines, right? Like so. But I want the vehicle below the non-grade lines. Voila, right? Now I don't worry so much about my error bars getting clipped elsewhere. I do worry about the error bar coming through weird, like I have here. And so maybe the error bar should come before the point. Let's try that. So we get something like that. I think that's probably good. I think that looks pretty nice. So that's the alternative to how to do it. Would be, again, to take your data set, put down the vehicle and or whatever it is you want to be in the background, and then to rerun the same geoms to put the data you want to highlight on top of that. Okay. Well, I hope you have enjoyed this and gotten something out of this. I hope you've enjoyed thinking about the benefit of combining data, right? And again, when I saw this and saw 12 panels that are basically the same panels with 2 different variables, or I guess 3 variables, right? The drug, the amount of diet, and the genotype. To me, that screamed facet. And it also said it's going to be hard to make comparisons across these. And these plots are pretty simple, and I think lend themselves pretty easily to faceting, where, again, without losing much, we can put those data on top of each other. We don't really care about the vehicle in the background or what they go with, because, they just don't really matter, right? Like, they're just not that different from each other. So, so I hope like I said, I hope you enjoyed this take and trying to refactor that visual to make this. As to the bigger question of like, why are there so many figures in modern papers? Read that newsletter. I have a hot take or 2 in there, and I would love some feedback. And if you're one of these people that have published a whole bunch of figures in a paper, by all means, let me know what you were doing, and why you felt that need to have so many figures in a paper. I think ultimately it makes it really hard to digest the data, digest what the authors are trying to say. And if it's hard for your audience to do that, then it's really hard for reviewers to do that. And I think that's a problem. So anyway, I will shut up there. The question is, can you change the alpha for the points? Absolutely. In this case, I don't think it matters, because the nothing is really overlapping with anything to the point where you can't see it. There's not that many points. I guess here you're maybe missing the blue point. And so you might think about dodging things or something like that. But you could certainly do like alpha equals 0.5 or whatever within geom point. Maybe as a parting shot, I will do that here right quick. And I'll do that with the drug not equal vehicle and geom point. We'll do alpha equals 0.5. Right, so something like that. And I don't know. I'm not totally sold on that. I think you'd want to make your line and your grid lines, your line and your error bar is also 0.5. But it's something you could do. And again, depending on the context of what the specific needs are for your data, you might think that's a good idea or not. So I will leave that. And thank you all so much for tuning in. Please tell your friends what we have been doing here. If you find figures that are open access figures in the Nature suite of journals, those tend to work really well for this, that you're interested in, feel free to send them my way. And I would love to talk more. And of course, if you would like to meet one-on-one with me or me with your group to talk through your needs in terms of training and consultation for design of figures, by all means, check out the link below and we can set up a time to do a complimentary session. All right. Well, thanks everyone. Keep practicing.